Okay, so Inkbird were kind enough to send me one of these Inkbird PID and SSR kits. So there's pretty much everything in here that you need control wise, so it's just down to you to obviously build a housing. This video is just going to be about actually point to point wiring up. We're not going to sort of go into full project builds, panel builds or anything. This is just basically what wire goes where. You will need a few basic tools, assuming that you're going to tackle this project. Some thermal paste for the SSR and the heatsink, some kind of wire stripper and terminal crimp. These are the real cheap nasty variants and slightly better style. They usually incorporate a wire cutter, and these type are the best ones. If you're going to go for a full panel build, these probably are worth an investment. These are the ratchet style, because I recommend that you prepare your wires, tin the wires and crimp them on, rather than just bare stripping and putting them in to the terminal mounts. Although that is your preference, you can just strip the bare wires. We have some cables ready to show you, but you could just strip it with strippers, twist it with your fingers, get rid of those whiskers, put that in, or tin it and do the same, or as we're going to do, connect them up onto terminal crimps, which is a better, more secure way of holding them in, and we'll go through that shortly. What's in the box? We pretty much get everything we need. We have a K-type thermocouple that comes supplied with it. These are a 2-wire type. You get your solid state relay. This is the 40 amp. There's 2 versions on Amazon at the moment. I have an offer code that will be in the description box. Obviously some of you folks may be watching it when it's too late, obviously, and it's also only UK Amazon. But you can take 2 options, 25 amp and 40 amp rating for your SSR. I went for the 40 simply because it gives me some redundancy. My other control panel is running 5.5 kilowatt elements. I've got 40 amp SSRs. If I have a problem, I've now got one I can pinch to get me out of the muddle. So we have the SSR, the heatsink, and the 2 little screws are also supplied to attach it to the heatsink like so. The bottom of these heatsinks has 2 grooves in it, which is to fit in a DIN rail should you be mounting it on a panel with DIN rails, or there are 2 holes to attach to a back plate. With that, you also will need to buy your own thermal grease. It's the same kind of stuff as you use for power transistors and PC processors. Just a light smear on the back and just sandwich them together and screw them down. So we have the screws, heatsink, SSR. There is the back mounting bracket, which is for the PID. And we have the business end, which is what we're going to discuss here. There is also a wiring diagram on the side. There's one in the manual, which is here. It's in English, reasonable translation. It gives you all the basic specifications, ratings. This is specifically for the 100VH, the VH denoting that it's the 100 to 240 volt SSR output. There are other variations of this. There's a 12, 24 volt AC DC, so that you can power it from low voltage. Everything else is the same. In the US there is one marketed called the 106 VH, which again, the VH denotes the use for SSR. Primary differences with that is their one is available to read Fahrenheit and Celsius. This one only reads Celsius. But the wiring is the same on the back. So it does explain what's got to go where, but that's where some people sort of start getting a little bit out of their depth, or wonder if they're going to do it right or wrong, or they mix up the different types of thermocouple that you can use. The sensors. You're supplied with this K-type. It's got an M6 thread For my sort of purposes, using it in the brewery, this is not one to be in the stream of fluid. I personally go for one which is the PT-100, which is slightly different. You just configure it on the menu inside to tell it what thermocouple you're using, because if not it will read display ORAL, which means it doesn't understand, or they're not connected properly, or something's faulty. But we'll get into what it does with the lights on another program. I just want to concentrate mainly on how to connect it up today. PT-100 probes come in, or any of the temperature probes come in pretty much any shape, form or design you desire. Long ones, thin ones, ones with just a little sort of connecting ring like this that will work as a temperature probe screwed to something. You'll notice the primary difference is with the PT-100 they have 3 sensor wires, whereas these ones only have 2. Okay, so I took this out of the bag so we can have a better look at it. It's about 5-6 foot long, steel braided, so it gives you a little bit of durability. These are a fairly generic type of connector, and the other style that I go for, very similar, same braided cables, just 3 cores. These screw in. What you would normally do with this type of sensor or a similar one, if it was going in the side of a pot or a kettle, you can have these thermo wells or thermal pockets, and they will just fit inside. This is attached inside your kettle, and you would just fit your probe inside. This one has a thread so you can put a gland on to attach, but we will cross over to construction in pots and things at a later stage. But this is something you could possibly consider if you're adapting it for other uses. The same with these are quick disconnect, and you can just take that apart. This remains in situ. This is connected like so. So where do they all go? Where do all these wires go? So we've managed to get this diagram, hopefully it's in shot. So the diagram is basically a copy of the side that you get with the sticker on it. So they're all numbered, which keeps it easy. You can't probably pick it up in the camera, but there is a number down inside the channel of each one that corresponds with the connection. So we have 1 to 5, 6 to 10, 11 and 12. Ignore this bit for the minute, this is your SSR connection. So we'll explain and go through it. To start with, your 2 power, be it your domestic supply voltage, will go into terminals 9 and 10 as shown in our diagram here. They are not polarity specific, so it doesn't matter what way around these go. There's a little bridge rectifying circuit inside that will convert it back to what the circuit board needs to work. You don't have to worry about positive and negatives on these 2. When it comes to your sensor circuit, you do, and also the supply out to your SSR. So what we have is pins 10, pins 9 would be your live and neutral supply in, or hot, depending on what your terminology is, where you're from in the world. I like to personally put the live supply in on pin 10, because these 2 here and this one up the top are for an alarm circuit. There is 2 options inside to program this up for 2 alarm systems. You can set to whatever temperature you want, the alarm will activate. So if you're using something like this little buzzer, this is 240 volt, you could have this connected up to it so that your feed supply going round just goes with a little loop straight into the common terminal, and then your relay will switch on and turn this one on if you want it as normally open, which means when the relay activates it will turn on. Or this terminal if you wanted it normally closed, if you were using this for say a valve or something, so that when the alarm turns on this actually powers off rather than turns on. So they're opposites. So we'll have our mains domestic supply coming in. These two deal with that. An alarm circuit, if you're going to use it, you have the option here and this one here. This screw is omitted and so is this one, because on these models it's not required. If you've got the internal relay version, there is a third terminal here for your common, for your relay output. Getting on to the outputs, this is for your SSR connections. So you'll have your minus connection and your positive connection. They're 12 volt and they will go to your input side on your SSR. And on the SSR you'll see there is a positive terminal and a minus terminal. So you have to get the polarities correct. And you'll see on the diagram, if it's showing, there's also a positive and negative, got to marry it. So we come to, I'll put a still up of this to make it a little bit easier. So your positive and negative for your SSR, your mains incoming, your alarm circuit, and over here is the other side which deals with your sensors. Now they're 2 and 3 wire. So we have for the K-type thermocouples with the 2 wires, they are also positive and negative. If you get them mixed up, then when your temperature is reading, it's going to go down instead of, if something's getting warm, it's going to go down in scale, not up. So you just need to swap the polarity around if your readings are a little bit screwy. Now on this particular model, they do recommend that you loop terminals 4 and 5. Some sensors require, others don't. Again, it shows it on the diagram here. It's just a small thin outline. Doesn't matter which one this goes into as long as you have the second loop wire in, so that these basically are both connected. Now with the PT-100 style, they have 3 wires. So your 2 blue ones, your commons, will go 4 and 5, and you'll have a single separate colour depending on what they mark them up as. But you're going to have, I mean, I've got one where they've just got the little numbered collars on them, so there's like 2 A's and a B, so you know B is going to go in number 3 and your 2 A's are going to go in 4 and 5. Now when it comes to turning it on, default these are set up to operate on K-type thermal sensors. So if you go and use something else that's not compliant with it at the time, it's not going to read. So you have to go into the menu and change it. It's covered in the booklet. Again, that's something else I'll cover on another video at a later stage. So we'll get on with just making some leads up and getting on with the point-to-points. So if you just want to go for the basic connection, that's all you need to do is just strip the cable down to an appropriate length and twist it and just keep it tidy. Just make sure you don't have any little whiskers sticking out that can cause problems later. What I'm going to do in step 2 is just run a soldering iron and tin the ends. Okay, so just a light dusting with the iron and the solder on the tip of the iron, and just run the braid through and the solder will pick up and tin the ends of the wire, and then just go on to crimping them. Of course, if you can't solder, don't have a soldering iron, this isn't essential. Okay, so that's our first 2 wires prepped, tinned and soldered. I've made the neutral connection and this is the live. Now at the same time I've took the time to make the little loop wire to go into my alarm circuit. Now when you're using the crimp terminals, you can see with my putty fingers that they are like little forks, and you can see what you want to do is put 2, when you're joining 2 into the same, just put them back to back rather than trying to squish them in. You can see the 2 barrels are getting in the way of one another. If you turn them back to back, they stay flat. You can just put a little bend in them and they'll sit in your termination spot a lot more neater. So here's a nice zoomed in shot for you. You can see the 2 connections and then the other loop going to the feed in the common port on the alarm circuit. So if we want to use that, that's there ready now. We just have to connect another wire to above it and supply it to the alarm. We could put a switch in circuit as well. Entirely up to you. So next we will do 2 wires that will go and turn your SSR on and off. Okay, so I've made some more leads up. They're a little bit long for this, but that does mean that I can obviously cut them and use them again at a later stage. So as a diagram on the back or on the side, you'll see on your own. It's not reflected on the light here, which makes it a bit awkward. But pin 6 goes to pin 4. It's on the diagram. Ignore the live and neutral bit on here. As I said, you don't have to worry about which one goes where until you get to the temperature probe and the SSR. So pin 6 to pin 4 on the SSR, that's your negative supply, and pin 8 to pin 3 goes to your positive. That enables it to turn on and off when the signal's sent from the SSR. So I'll hook them up for you now. So hopefully you can see that. Basically, if you look at the relay and face the SSR together, you'll see the negatives at the top. That's got to go across to this side, and your positive is down here, and that's got to go so they line up. Basically, I've already attached this to the heatsink with a little bit of thermal paste. A little tip here is if you ever do go to change them and you can't get them off, they're rock solid, like they're glued on, and this happens with PC processors too, is over time the stuff gets so hard it goes like glue. If you use a little bit of contact cleaner, the alcohol based contact cleaner, or some IPA, isoprenyl alcohol, run that round, that will break down and you can get them off without having to sort of get screwdrivers in there and prise them off and end up doing a lot of damage. So as you can see now, we've got the thermocouple sensor connected up to pin 4, which is the positive, indicated by a red marker on this particular model, and the negative is to pin 3 as indicated with a blue. Now I haven't yet placed a link in on this one. It's depending on the type of one you use. You may or may not get stable readings from the unit. It sometimes helps, but in the instruction manual it does suggest that you do that for this particular one. As I say, in my situation I wouldn't be using this, but for the purpose of this video, this is what the kit supplies you with, so we'll stick with this one for the minute. So I've got my power connected to a quick test block, which you probably just see in shot there. Obviously if you were building this into a box, you'd want some form of fuse to protect your load on your SSR and the feed going to your PID. Obviously in the UK our plug has a fuse 13 amp. The supply rating obviously on this isn't 13, so you'd want the lowest ampage fuse, because you're only powering this unless you're going to split it off and run the SSR off a plug top. Then you're going to want to put a smaller fuse, one of those little panel mounted fuses, just to cover protection on this, because obviously these two are going to be live. Earth again we haven't covered, because you may be using a plastic box to build it in, or a timber one. You may want to consider that your DIN rail that you mount this on is earthed. If there is a failure and the leakage current goes through to this, you're going to have nothing. If you go and put your hands in and get an electric shock, if you've got an earth connected to the bar that terminates on this somewhere, and you have a trip circuit on your fuse system, hopefully at home, you've got a modern one, it will switch it off before it does any damage to you or your equipment. So it's that time. There is an internal fuse on my quick test and obviously one on the plug top, so being careful not to touch anything round the back, we will turn it round and see what happens. Turn the power on. It does the self test, looking at the set value. which is the same as when I bought mine. It's preset to 50 degrees, that's the target temperature, and your perceived temperature is 17.6. Now, to make sure that we've got those two wires round the right way, the simplest way is just to get hold of the probe, and if my body temperature raises it up, which it is, we know we've got the two wires connected round the right way. So that will keep going until it reaches the 50 degrees. Now, you could set your alarm to operate at 50 so that you've got an audible visual indication that you need to turn around and do something. So all that remains, once you've done all this and built it into your appropriate little box, cabinet, control panel, whatever you're using for, is to connect up your power into on pin 1 and out on pin 2. Be it your heating element, for if you're doing a brew kettle, or furnace, oven, whatever you're using it for, all this is the same. You can see the little light on, which means that there is power going to the SSR if it's showing up on here, just about. Which means obviously its set value is 50, so it's trying to energize and heat something or do something. Obviously we've got nothing connected to it, so but that's pretty much it. So if there's any questions, I will endeavour to try and help you with as much as possible. I know some people are going to say, yeah, we need videos on setting them up and programming them. If you go on to the Inkbird website and go to their download section, look up the model number if you're a 106 user or a 100. There is obviously a copy of the manual, which is a little bit easy to read because it's in larger print than the one they supply. But also there is another section there on a PDF that you can download or read, which does go through some of the fundamentals of the settings and how to change them and what the variance is them on. But generally the system's going to learn your system. So, you know, if I tell you, if I build something and my settings are not necessarily going to work for your settings. So it is a case of learn by doing process. And there is a function on these called auto tune, which you can run through. You might have to run through it more than one time to nail down and get the most out of the unit, but that's pretty much it, folks. So in the future videos there will be a build utilising these components in a little panel box and a conversion of a catering boiler to an all-in-one style brewing system, but other projects are pressing at the moment, so that will probably be in the summer or autumn of this year before I get a chance to really go and do anything else. So that's it. But again, any issues, shoot me up. If there's anything you want me to cover in detail, I can always try and cover it in a supplemental on a Homebrew Wednesday or anything. Cheers then.